So I celebrated my 39th year with Siemens a few weeks ago, so next year is the big 4-0. So as Andrew said, I started as an apprentice, so I worked with Siemens in the UK, Germany. In fact, I've travelled all around the world with Siemens. So it's a really exciting company to work for. So really today what I'd like to do is talk a little bit about Industry 4 and the impact on digitalisation on all our lives, whether it be domestically or in business. And a little bit about where we fit into the grand Siemens organisation. So we have 9 divisions, and the sectors that I actually am responsible for are Digital Factory Division and Process Industries and Drives. So I'm the CTO for both of those divisions. Both the head office is in Manchester down the road. But I've actually worked with most of these divisions in one way or another. So Siemens in the UK, we have 15,000 employees, and we also have 15 manufacturing facilities in the UK as well. So one of my challenges is we sell the technology, so we sell the software, the virtualization software, we sell the automation, the drives, the low voltage control equipment, but we also utilise it in our own factories. So you know, we eat our own dog food basically, as some people refer it to. So what we tend to do is anything new or new idea, we try it ourselves. And we develop it ourselves in our own factory to make our own manufacturing facilities more globally competitive. And then we also then try and introduce it into our customers' manufacturing facilities. So there's a lot of people that I present to don't really understand the background to Industry 4. Why is it called Industry 4.0? So I apologise for teaching my granny how to suck eggs, but I'm going to go right back to first principles to explain what Industry 4 is and then what the actually technology behind it are and the processes and the philosophy. So in actual fact, I actually sometimes refer to the 4th Industrial Revolution as being Britain's 4th Industrial Revolution, because we started it all off in the UK. We started the 1st Industrial Revolution, and that was all around technology. And that was around water and steam driven machinery. So Arkwright's spinning frame and Samuel Crompton's spinning mule meant we were the centre of excellence for the mass production of cloth. So we started the 4th Industrial Revolution. The 2nd Industrial Revolution was when we started to see mass production, so conveyor systems. And the first examples of that apparently was in the Cincinnati slaughterhouses back in 1870. And we all remember the Model T Ford, well some of you will anyway. The Model T Ford, you can have any colour you like as long as it's black. It's all about mass production of the same products over and over again, going as fast as it possibly could. The 3rd Industrial Revolution was when IT started to be used in manufacturing. And this is where we started to see the likes of programmable logic controllers, PLCs, automation being used to control machinery. And Siemens' very first PLC was called a Somatic G, and it was announced in the Paris Machine Tool Fair back in 1959. So we've been working with automation for quite a few decades, a bit before my time, I'm afraid. The 4th Industrial Revolution has already started, it's already happened. You'll see some of the technology I'll explain about in a minute. You already see it in manufacturing today. And you'll notice I've got a bracket around the R. So if you was to build a brand new facility to manufacture something, it would be a revolution because you use all the technologies, you've had robotics, virtual reality, augmented reality, all this great stuff. However, in most cases, what it will be, an existing factory that you want to become a digital factory. So it'll be an evolution. So a lot of these companies that I work with, a lot of companies that were mentioned earlier on, actually come to me and say, well, where do we start, Alan? I don't know, you know, is it communications? Is it virtual reality? Is it robotics? We don't know. And it will vary from one company to another. And one of the things that we do, we help organisations understand where the quick wins are, and we also point them in the direction of organisations that can help them de-risk those investments, such as the catapult centres. So that's why I spend a lot of my time with the catapult centres, helping our customers de-risk some of those investments. And Industry 4.0 is all about these technologies, very similar to the slide we saw earlier on actually. So I think I've got it right. So virtual reality. So this is all about virtualising your manufacturing layout. It could be about virtualising your products. It could be virtualising people, ergonomics, looking at the effect of the skeleton on people when they're working in a cell. And we're starting to use that technology in our own factory down the road in Congleton, where we manufacture variable speed drives for the world market. Augmented reality, this is all about helping the operators get more information. So if you're an untrained person and you're going to work on a machine for the first time, usually you have to spend half a day or a day just learning that actual environment and what to do. With the augmented reality glasses, actually it could point you in the right direction. So it could minimise the amount of training you need, and it also could increase product quality, because actually it'll tell you when you do things wrong. So augmented reality will change the way we assemble and manufacture products. Digital twin, so digital twin is having a virtual model and a physical model. So you design everything in 3D CAD, you test it in the virtual world by simulating the process, then you migrate it to the machine. So that's one-way traffic from virtual to physical. Cyber physical is that next step. So we've got a virtual model, a physical model, we start to make things and we feed the data back from the manufacturing process into the virtual world. And that's what we call cyber physical systems. I'll explain that in a bit more detail in a minute. Big data, we've all heard about big data. Well, big data doesn't do anything unless you do something with it, unless you harness that data, whether you filter all the data out that you don't need and then make use of the data that you do need. And this is where we're starting to see lots of organisations and universities developing smart algorithms to make some sort of sense of that big data. The Internet of Things, so there's more and more connectivity into the outside world from more and more sensors, machines, processes that have that connectivity into the Internet. And the Internet of Things really is driving those. So, for example, there's lots and lots of small sensors now that have connectivity into the Internet, to the outside world. They're becoming smaller and smaller, smarter and smarter, generating more and more data. Advanced robotics, and I don't just mean big robots in big cells, although they are important, in big cages, but also cobotics, so robots working alongside humans, supporting humans, doing the repetitive work more accurately and more repetitively, consistently, and the humans working with the robot in a creative way. And many people think that robots are going to take over all our jobs and we'll all be out of work. Well, if you look at all the figures, if you look at those countries that have the highest use of automation and robotics, you'll also find they've got the lowest levels of unemployment. So what we found in our factory, we want to keep the same number of people that we're employing today, but we want to increase productivity, we want to increase value of the product and upskill people. So we've got some great examples in our factory where our operators are now doing degrees and they're helping the apprentices understand new technologies. So upskilling is really, really important. Cloud technology, that's accessibility of data, either within the factory or globally. So you've got a common data platform, a single existence of the truth. 3D printing, you've probably heard of 3D printing before, mainly with plastics. But in the engineering world, they're also using the 3D printing type technologies for manufacturing mechanical piece parts, metal piece parts. They refer to it as additive manufacturing. This is where we have metal powders and you laser sinter an actual layout and it builds up a shape of a product. So you think, well, what's the point of that? Well, the one benefit is you can make single piece parts, whereas in the past it may be several piece parts. So like a fuel injector, for example, can be now manufactured in a single piece part. So these new technologies actually, if you think about it, are changing the way we manufacture, increasing productivity. And last but not least is cybersecurity. So if you speak to any managing director and say, look, any sensor on your machine can be accessed from anybody in the world, he'll say, right, take it off. So there's ways of de-risking those some investments and some of those challenges of managing data. And cybersecurity is absolutely essential. And you can do it in a safe way if you engage with the right people and the right organisations. So that is, in a nutshell, what Industry 4.0 is about. And it is more of an evolution than a revolution.